Good morning. I am Praveen HR, B student from Mechanical Engineering from PES College of Mandya. Now I am going to explain about gas turbine in fluid mechanics and machineries. Let us see the concepts what we will study in this gas turbine. We will going to study about introduction part, components of gas turbine, working principle of gas turbine, advantages of gas turbine, disadvantages of gas turbine applications, and conclusions. Let us see now the introduction part of the gas turbine. Introduction part of the gas turbine. Gas turbine is a type which of the internal combustion engine that operates on a continuous cycle, which means it will be a continuous cycle, which means like a piston. It will be a operating on repeatedly, converting chemical energy into mechanical energy. It means any chemical fluid or chemical energy will convert it into mechanical energy or mechanical force. It's versatile technology found in various applications from aircraft propulsion to power generation. It means it will generate high power, which means it is used gas turbines mainly. It is used in aircraft and rocket launching. For it will generate high power. That's why. Let us move to the working of the gas turbine. Let us see how it will work. We can see here inner part of the gas turbine, which it contains a shaft, shafts device or other device, turbo sections, compressor sections. You can see here. Here the air enters, which means which means atmospheric air will enter here, and it is compressed here, which means here can see compression section is there. Atmospheric air will compressed here, then it will flow to this combustion chambers, which means temperature and pressure will increases. Then it will uh, exit throughout exhaust exit. Let us see the working principle of the gas turbine. I have already told that the gas turbine operates on continuous cycle, which means it will repeatedly cycle. It will be repeatedly generating or power. It will generate repeatedly. I have told that already a gas turbine operates on a continuous cycle, which means it will repeatedly generate a power, which means it produces high power. Let us see working of this gas turbine. Air air intake. It means the process begins with the intake of ambient air from the atmospheric air, which means it sucks the atmospheric air and it will passes a compression, which means it will flow flow to compression compression chamber. The incoming air is drawn into compressor where it is compressed to significantly higher pressure. This compression process increases air temperature and density, which means the air will enter the compression chamber. Then compression chamber will compress significantly, which means it will increases high pressure. Then combustion chamber. The, the compressed air is then directly into the combustion chamber, which means air is compressed uh, and it is increased high pressure. That high pressure air will passes directly passes through combustion chamber. Fuel such as natural gases or liquid fuel is injected to the chamber and treated. The fuel is injected to the combustion chamber. This combustion process generates a high temperature and high pressure gases. Expansion. The hot high pressure gas expands rapidly throughout a turbine, driving its blades and generating rotational energy. Which means it will generate a rotational energy, which means shaft will rotate in rotational rotational side. This rotational energy can be used to power power generator for electricity production or to directly driven drive machinery. Exhaust. Finally, the expanded gas, now at a lower temperature and pressure, is expelled to an exit nozzle, which means it will exit throughout a exit nozzle. Let us see the advantages or uses of the gas turbines. It is gas turbine is mainly high efficiency. Modern gas turbine have the thermal efficiency, meaning they can convert a significant portion of the fuel energy into useful work, which means we send the chemical energy, it will give us a useful work as a mechanical energy output. It will it will very simple maintenance compared to other turbo machineries. Long lifespan, it means compared to other turbines, the gas turbine is having a long lifespan. Versatility in fuel types, which means they can operate a variety of fuels, including natural gases, diesels, even some more liquid fuels. But the quality quality of the mm, quality of the fuels mm, cannot cannot be changed because it will affect a gas turbine and lifespan of the gas turbine. High power to weight ratio. Gas turbines are compact and lightweight for the amount of power they can produce. Let us move on to the disadvantages of the gas turbine. It is a lower efficiency at partial load. Their efficiency tends to decrease significantly when operating at less than full capacity. This is because a significant portion of the energy is used to drive the compressor regarding of the power output. High fuel consumption at idle or low loads. Versat- uh, Versatility to fuel quality. I have told that in advantages. Uh, it cannot be changes in the fuel quantity because it will affect the performances of lifespan of the turbines. Noise pollution mainly the long long the big disadvantages of this gas turbine is noise pollution. We can avoid noise pollution regarding soundproofing measures and carefully sites. Let us move to on applications means it where it will uses. In basic load power plants, it means this will used gas turbines is mainly used for power generation. That's why there are. I have already told that there will be used in aircraft, combined cycle power plants, base, base load power plants, unmanned aerial vehicles, ships and submarines. Gas turbines are used to power a wide range of marine vessels, including warship, cargo ships, and cruise lines. These are the main applications of the gas turbines. Gas turbines are a versatile and efficient technology. In this gas turbine, we conclude that by concluding that gas turbines are a versatile and efficiency technology with a wide range of applications in generation, emission, marine pollutions, and various industrial processes. There are advantages include high power to weight ratio, fast startup times, fuel flexibility, and relatively slow emission compared to other fossil fuels powered engines. These are all we have discussed in advantages. However, they can also have drawbacks such as, which means drawbacks means which disadvantages we have discussed: low efficiency at partial road, high fuel consumption at ideal, and potential for noise pollution. Thank you, sir, for this opportunity to present a concepts of fluid mechanics and machineries. We have learned a lot more from this subject. Thank you for all, sir.